that's positive.
Mm-hmm.
So when velocity is positive, which way are we moving?
Right.
Cool.
So it would be. Hold on.
Zero.
This
Zero.
Like if the acceleration.
Just to 1.
0 to 2.
Yeah. All of this is positive velocity because it's above the x-axis.
Oh.
Because this is a prime. This is p prime t. Why did I get
This
this?
is v of t. Yep, and p prime. Yep.
Why did I get this suddenly? This is weird.
Okay, so it's from 0 to 2 and from 8 to 10. Is that what I said?
7.
7 to 10, but yes. 0 to 2 and 8 to 10.
I gotta put the little u in.
It's 7. She didn't.
Oh, she did down.
Because, oh, you're right. Thank you, Wynn. It is 7. I even said it was 7 and then didn't do it.
I also said it was 7.
Because I'm sorry. Thank you, Faith. Because v of t is positive.
No, I also did the same thing you did.
Is that what you said?
I literally was the one who answered this question, and I put 8.
Okay, so left.
So from 2 to 7.
2 to 7.
Yeah. Let me change colors. Left would be everywhere where it's negative. That is from 2 to 7. Because v of t is less than 0. So the direction that it's moving is whether velocity is positive or negative. Position just tells you where it's at, not which direction it's moving. Okay.
What is up with you?
I'm just trying to find a new way to say yes.
Find the average. Find the average acceleration of the particle on the interval 1 to 8. Show your work. How do you find average?
The slope.
The
The v of t minus v of whatever.
V of A minus V of B.
V of t1 minus v of t2 over t1 minus t2.
Yes.
A V of
You're welcome.
1.
Thank you. Yes, Daniel.
Good.
I said no with my first answer. She said, Daniel, just be quiet for a second, please.
Let me get it wrong.
V of 8 is 3.
I couldn't think.
But so is V of 1.
So it's
Over
nothing.
7 is 0 over 7. Right? Yeah.
I don't know. Whatever I just wrote is ugly.
So it's 0. What are the units here?
Meters per second squared.
Yes.
We're doing acceleration.
Agreed.
Very good.
It's not moving.
Well,
It's not moving because it went back to where it started.
Right. That's average acceleration.
That's physics.
I'm not in it.
I'm not either. Well, I'm in it, but I couldn't tell you what I'm doing.
Cheer.
Okay, definition of net distance.
I know the word.
It's
Net
net
is
is
another
another word for average. It's total, right?
No, total. Net is how much it actually moved. So like
This is kinetic energy.
if I guess I should do this here. So if I start here and I move to the, this would be your right.
So
If I move to the right, 1, 2, 3, 4, and then I move, these are blocks, and I move to the left, 1, 2, my net distance is just 2, because that's how far I've moved. But my total distance is 6, because I moved 4 and then 2 more.
Net distance would be like velocity.
Net distance is going to be like if you add.
Net distance is the distance
From the starting point.
from where, yes, that's where.
Final resting.
Where the object begins and where it ends.
That was a lot to say to start.
I know.
And then the total distance is the sum of all distances
Well, what's the difference?
moved.
Is that your so like the distance like the difference is like because she moved a total of 6 blocks, but because she's only 2 blocks from her beginning point.
It was 2.
Yeah, for the net.
So, Faith,
One says like X, one says like Y.
Faith, you're my beginning. Okay, right here. So I moved. Watch my blocks. I moved 1, 2, 3, 4 this way, and then I moved 1, 2 back this way.
So you only moved 2
I only moved 2 blocks. That's my net distance.
Oh, yeah. Okay.
But my total distance is 6.
Okay.
Some people want to take all understand all year. If this is on the test, if they want me to know the definition, I can write that just now.
Okay.
Starting point.
So if a particle is moving the same direction the entire amount of time, they'll be equal. That's right. The net distance equals
That makes sense.
good. The total distance. Okay, so to find the net distance on the interval A to B.
Are we getting another equation?
The net distance, well, it's just kind of like, think about it.
Well, you said A, B.
An object travels is P of B minus P of A. So the ending distance minus their starting distance.
You forgot the word of. Sorry. It just bothers me.
Yeah, it's the net
Of.
distance and it. Oh, this I worded really good.
After
What?
distance.
After distance, it says the
Oh.
net distance an object travels.
Yeah. No, on the interval A to B, the net distance an object travels.
That sounds wrong in my head.
It sounds right.
Why does it sound so wrong in my head?
I don't know. I mean, you can have the of, but you also sense fine without the of.
What are y'all talking about?
Well, the net she's saying the net distance of an object travels, but it says the
That
net
sounds-
distance an
that
object
sounds-
travels.
I don't know. It sounds weird.
You can put it there if you want.
I did.
Okay.
In my head, it belongs.
Like an object that travels.
So if you just subtract where you end from where you start, that should give you the distance.
And we'll stop there for today.
Yes, I agree.
The next one, to find the total distance a particle travels on an interval. That's the total
Provided.
distance.
You're
Provided
asking
the
me
object moves the same direction. Oh, I should have absolute values here because it can be negative
You're right.
because it's a distance on the interval A to B. The total distance is the same, we said, if they go in the same direction. Direction. My goodness. So it's P of B minus P of A. But if the object changes directions, at, we'll say T equals C, then total distance is P of C minus P of A plus P of B minus P of C. And there's where
I
we'll
can't wait
stop.
to be confused later.
I can't wait. Oh, Faith, that was great. No, see, you
I'm
won't.
glad I understand that there needs to be absolute value signs there.
I definitely would give you a negative.
Yeah. It's kind of like a time thing.
And so also, since they're absolute values, you can have these flip-flopped and it's not going to make a difference.
Cool.
Yeah.
This is probably the biggest, like, notebook I have.
Miss King.
Yes.
See all those